welcome back. Today in this video, we're going to go through another application of differentiation. In fact, we're going to compare delta y and dy. Just to remind you, dy is the differential of the function y, and delta y is the change in the value of y. And we're going to use the differential concept to sort of like approximate to the actual change of y. You're given in the problem y to be x to the fourth plus 7, and the point is also provided us to be -2. And we're going to choose delta x and dx to be 0.01, and we're going to calculate dy and delta y. Let me just remind you about the definitions of delta y and dy. Well, delta y, to start with, is the actual change in y. Jumping from x to x plus delta x, you check how much the function values change here. And you can approximate that value by using the differential concept, which is dy equals f prime of x times dx. All right, so y is provided us to be x to the fourth plus 7. And dx and delta x, so net change in x is in fact 0.01, and x is -2. Okay, and why don't we go ahead, write down the change in y, delta y. Okay, so this is going to be f of x plus delta x minus f of -2. Well, this is -1.99, and you can go ahead at this moment and use your TI-84 to find the function values at -1.99 and -2 for this function here. So this is your f, in fact, right? You can just label that as f of x. Okay, so this turns out to be -0.318. And if you switch from x equals -2 to x equals -1.99, the net change in the function value would be exactly equal to this number. So the function value is going to decrease. The difference is a negative, right? The function value is decreased this much. All right, so let's go ahead and find dy. dy requires us to find f prime. So f prime is equal to 4x cubed. So that essentially means that, so you have -0.32. As you see that, this is a really good approximation of delta y, because delta y turned out to be this number. And this is exact, as you see, this exact number is 0.32. So that's a reasonable approximation depending on the type of the problem. But we can perfectly go ahead and say that dy is approximately equal to delta y. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.